we synchronizing for the video?
Okay, I've already started the video, so you can now do a clap.
Yeah, so obviously Mickey couldn't make it. I hope he's not stuck on the N3.
No, that's fine.
I don't know whether he needs the N3 to come.
You can tell them what they missed out on.
They can watch a video.
Oh, okay.
Yeah,
Sorry. I'm just changing it to,
the resolution.
no, just so that it duplicates instead of having it there, but that's fine. Okay. Alright, so basically I'll be talking about just two PC boards, just put that down a bit there, and how they can work with the repeaters at the repeater sites and whatnot, and how they are related and that. And it's supposed to be about 20 to 30 minutes, but maybe I'll make it 10 minutes, we'll see. But yeah, hopefully it'll be a bit educational and informative, you know, just some challenges and whatnot. I was mostly going to be focusing on this, which is the VOTER. It's similar to the board that's been damaged at Griffin's Hall quite a few times. And this design is actually by a fellow named Jim Dixon, and he passed away quite a while ago, I think in 2016 or something. But he left us this opportunity to make boards like this, so that we can have fun and you can learn new things and whatnot. So I've got a few examples here, and I've got my own board, which is basically going to hopefully monitor the power and, you know, temperature and a few things at a repeater site, and it runs off a Wi-Fi chip. So I've got one here that's a little bit populated. Haven't completed it yet, but this is how it looks. And yeah, people can come and take a look and whatnot if they're interested, but I don't know.
Are those the blank boards, Cale?
Yeah, so I've got two blank boards and then one fully populated one. The chips arrived yesterday, so I didn't have time to program it or anything. But I thought I'd just bring it to show people instead of just showing people pictures, you know. So that's basically how it is. But I'll get into the slide before I go off topic for too long now. So. But yeah, and I was thinking, you know, I might as well just make a slide. I didn't want to do something overly professional. You know, I'm not doing a seminar here, but I'll just make it look at least half decent, so you know people can hopefully get something a little bit more out of it. But yeah, and recording it I think will help. But I can always do it again or do something similar, because there'll be follow-up projects. Once we install this, or I'm hoping we can install it. I was hoping to talk to Koos about that today, and then we can use this, and it has an online system, so it connects to the internet, and I've built like a dashboard and whatnot, and you get all the information from this, which is pretty cool. So that could be another video at some other point. But let me get into this, and then we'll continue. So yeah, basically repeater stuff, that's it. Got the Griffin's Hall picture there. That's the amateur box, so it's a little box outside the building. And there's the VOTER, and then there's my board. I'll have some close-ups of it just now. I'll go into the software that I used to design it. But yeah. Alright, so that's just a little joke. Don't be that dude shocking himself on the radio there. You know, if you don't ground it correctly, he's holding the mic and then he's touching it and he's creating a circuit there, so that's all funny. But yeah, so the introduction, I basically just went over that now anyway. So just talking about those two boards, 20 minutes, educational and informative. And afterwards I have this all-star node. So let me just show you that. I don't know. So basically I made it on a proper breadboard. So you can call it the all-star breadboard, I guess. It's not, you know, I've got tape and the tape's coming off and whatnot. It's just for presentation, you know, I've labeled the different parts. So they're all modules. But again, I'm hoping to create my own circuit board with you know, certain things. And of course, I haven't chosen the best things. Like there's a lot of noise with this step-up converter. You know, it steps up the battery's 4.2 volts or 3.7 volts to a 5 volts for this Raspberry Pi. And then the radio needs a lower voltage now. It can't work at 5 volts, so you need another step down converter to step it down to 4 volts. And there you've got your sound card, which technically, this, on a bigger repeater, this voter is technically the sound card in the system. This is just a smaller, this would be your repeater if there was 2 radios here, transmit and receive, getting power. Anyway, it's just a nice thing. And then of course I've got the USB flopping around here on the breeze of it, but yeah, I was hoping, you can look at it up later and
So that
yes.
works off our network.
Yeah, so that works off Wi-Fi. That's how you connect to the internet, and then of course your radios would be UHF because that's a UHF radio. So you connect to it, and it's analog. It's not digital. So it's all-star basically. Yeah. All-star analog. But you can control it with a computer. You can set certain things. You can set DTMF and whatnot digitally on your computer, but it's an analog system. Okay, so then this is just a brief history on myself. So I was basically started working with electronics in 2015, and then I moved up. So I was a technician, so we were working on trucks and whatnot. I've got some photos, so I'll go to that quickly after this, and then I'll continue. Network administrator, so I was basically doing the Wi-Fi and whatnot at the company, and then software development. So that's basically my history so far. And right now I'm still doing software development. But I've always had the hobby of working with electronics. It's nice to play around with it. And that time I didn't have a radio license or anything. I was just playing with electronics, and when I saw that, I can actually play with electronics with a radio, then suddenly I had a much bigger interest in radio. You can ask my dad because he was a radio amateur, but I never really thought of it that way, So I do have a few photos here that I can go into. Just to show a short, I've got different ones we can zoom in and whatnot, but just to show you a bit of the history. So I'll go into them and I'll just go over them quickly. So basically that was my first job, soldering these cigarette lighter sockets for trucks. 2015-01-28, I still have the date, and when I was researching this product, I looked at that and I said, flip, that's over 10 years ago. That was my first job, and I still have photos of it. It's crazy. There they all are in a row. So that's all I was doing, soldering these things. But there's good experience because I actually took some close-ups. And I was hoping there'd be more people here that I could show. Looking back at this now, I can say to my younger self that I would have actually put some insulation on, because if you see here, it's a bit sharp, I would have made it more round and put some insulation and made it a bit neat. And that's what people pay for. You're going that extra mile. You're not just soldering and slapping things on there. You're actually maintaining it and looking after it and giving it that extra care. And that can give you, a boost. So anyway, that's the setup. So I was working with these devices, but before that, then we had these trackers. So I'll just get to them now. Just GPS trackers without cameras. So these were camera devices basically that I started working on. They've got a whole system, and that was my system, the rack on the side there. That's how it looked there. There was different versions I created because the first version I didn't understand how amps work and whatnot, So I had this thin wire that was running like 30 amps, and it was getting warm, and I was thinking to myself, hey, I can use this thing to warm myself up, it's not bad. I can use it as a dual purpose thing. And then when you learn things and you get experience, then you're like, hey, that was not such a good idea. Luckily it never started a fire or whatnot. But it shows you how you learn experience. It's,
Kill yourself.
It's interesting, yeah. So, okay, this was a call cutter. So this is similar to this VOTER, voice over internet, VoIP basically. But it's not, that's for, you would have that in your office, but it's a similar principle. It connects to the internet. So I found this picture, 2016-04-20, 4.8. I thought to myself, I actually cannibalized this. So I took all the parts off of it. At that time, I didn't understand what it was. I was just experiencing with different parts. And now looking back, I still have some of these parts. You actually use ultraviolet. Yeah, you shine it on the EEPROM and it erases it. So that was an interesting thing. But I look back at it and I'm like, look, I had this system. I could have kept it and it would have helped. You can see the call cutter 4x4, whatever. There's different modules. That connects to the telephones and whatnot. Yeah, it's got the RS232. But anyway, this is not radio related. I just wanted to show you guys some of the history. There's some of the devices upgraded, and eventually I got to a point where I had full racks, a full system. So I was managing each one of these. I had a conduit and everything. So yeah, that's our office. And these were the first devices before we got those video devices. So that's just the history. Maybe I overshared a little bit too much. But I took a walk down memory lane when I was researching and thinking of the 10 years ago, so whatever. And there's some circuits with a breadboard. And actually, Brian, who's passed away, he gave me this breadboard. So I thought that was a bit relevant. When I first started building circuits and whatnot, 2015 or 2017, so very long time ago, I used a breadboard from Brian, who's now Silent P. So yeah, I thought that would be relevant. But anyway, let me go back to the slide. Right, so that's the short history. I hope it was short. Alright, so what got me interested in this particular story with this voter, it was the issues at Griffin's Hill. You can see there's an example there where the PC board has been damaged. That's the power supply chip. So I looked online, you can get these chips still, but they're very expensive. You pay probably about $200, and then plus shipping and whatnot, and then importing, yeah, you pay $1,000 for one chip. Unless you get things in, you buy a whole lot of stuff in bulk. There's a schematic of the chip in that. So it's very expensive to buy these things separate, and now, okay, that's okay, So I thought there must be a way to make it yourself. And this fellow Jim Dixon made this board that we can do it. We can make it ourselves. We can perhaps sell these type of boards manufactured if it becomes viable. People are not going to be using different things like this, all-star node. If you want to have it in a repeater site, I'll do something like this. But as a private thing, all-star node is a great thing to have. And to encourage younger people, hopefully we can get some more younger people involved in the club. And they can build this and get excited, You go to something else. You don't have to use the radio I'm using. Anyway. But that's basically what got me interested. So, working there, our course is there. There's a photo of course showing the overloading of the power supply. So that just means that it was not connected, basically. And that's when we started opening the boards and really looking and now trying to, evaluate what went wrong. And we basically came down to rats, lightning, and internet problems. So rats making their nests. So we need to solve that problem. Lightning, which is relatively easy to solve. There's many protection things, but I don't know if we are using those methods, proper breakers, proper returns to ground and whatnot. And then internet. The internet seemed to be the biggest thing. We've got a Wi-Fi router there. You can see them just circling it. But it's not, it's actually not, sorry, actually I didn't start recording yet, so I just realized I haven't recorded the screen. So I'll just activate that if that's alright. Be a minute. Because this is going to be clearer. If somebody starts looking from the phone, it's going to be a bit of a pain. But yeah, okay, I'm recording now. Good news, okay. So yeah, so some people have had issues with the Wi-Fi. You would normally, because you're so close to radio towers and signals flying around, it can overload the Wi-Fi signal. The RF can get into the PCB board, into the actual dielectric of the board, and that can damage it. So having just a router like this, sometimes you would want power that goes to a separate board that's shielded and whatnot inside the room. But that all is going to cost extra things to do. We need to route the wires, and the wires have already been routed and whatnot. But if you want to do it properly, you've got to do it properly. But maybe we can get away with it. But we'll see. But there are better ways to do certain things. So that's basically what got me interested. The next thing is basically my board. So when I was interested in this, I was thinking, all right, what can I do to try and help, try and get involved? And that's where I created this little board here. I'm actually a few versions higher than this, so this is not the one that I'm currently on. I've already done this one. There's other ones with already much more things have been improved and whatnot. And this still has the same core functionality. There's just cheaper components. I might have thought of designing things slightly different. Like for example, I've got a screen on here, but when it's in the repeater site, nobody's looking at the screen permanently. You know what I mean? It's just there. The screen was there for feedback, so the guys would press a button and they could see, all right, this is the monitoring statistics, it's connected, etc., etc. But yeah, so that was now exciting. I can see how can I contribute to this. But basically, my list of needs or my goals that I wanted this board to fulfill are listed here. So I basically wanted parts that are 1206. So they're surface mount parts. They're not through hole like this board. So you can see this voter is through hole components. You can see they go through the hole there. surface mounts components are mounted on the surface like this. So I'm sure you guys are familiar with that. But I wanted a size that's big enough that I can solder it, but not too small that you can make it more cost effective by having it smaller, but then you can't solder it. It's not a project. So that's just for myself. There's current measurement, so that's this part here measures the current. This chip can handle up to 30 amps, which I thought was perfect for the the repeater. I can change it for other ones, but just for testing purposes, I got it, and I made the tracks thicker, and I'm going to put extra solder on it. I added some extra diode protection and fuses in there. So I've thought about all those things. So that's what I added to that part for the currents. It's going to have internet, so that's so that it can talk to us. So if we want to log into it from a remote location, or maybe Sean or someone was here, then they would be able to monitor this. And I was thinking of different versions. So at the moment I've got my own website that I've created for monitoring it. So that's the interface, your login. But I can have it pass information to other websites, so other people could use it in future. So if other clubs wanted it, this would send what's called a JSON. It's like a string of data, and they can just take that and pass it, and then use that data. Anyway.
What type of things is it monitoring?
So this is monitoring the battery.
Okay.
But there are a few peripherals that I have added. So that's what I'm getting into now.
Okay.
So it's got the current measurement. That's a big fat one here. Then it's got peripherals. I've got about 5. So the peripherals are a reed switch. So the reed switch is like a magnetic reed switch that your alarms use. So this board can actually detect that if it's opened or closed, and that's going to be for the door. So if somebody opens or closes, the magnetic reed switch will switch on or off, and then you can see, the door's been opened. It's a nice thing to have. You can use it for other things as well, because the reed switch will be connected by a wire. So it could be technically any other input, like a digital input, or it's a short to ground technically. That's one thing. Then there's a digital input that could be anything. It could be a button. It could be an input that and I have protection diodes and whatnot which I added. It's the same as what I used when I was working on the GPS boards and whatnot. Because back then I was also experimenting, and there's different ways that you can have protection. But they also get to a point where you can have a trade-off between protection and functionality, and then protection and cost, and but I'm not going to get into that now. But and then I've got a digital output, so that could be a siren. You could connect a siren to this if something was happening, or you could connect a pepper spray if you wanted. It's a little bit more militant, but anything you could. It's an input, output. Anything you would like to output, a relay that switches something, that does something. It's just an input, and I can have more of those functions. I just included one for each because again, this is me experimenting. In the future, if it becomes a thing, then I would add more. Alright, then there's a voltage detect. So that's important because that detects that there's a voltage coming into the battery or not. I've got a mains detect for this board because it has its own backup battery. So even if that battery died, this board still will have a small lithium ion battery on it, powering it and sending internet, as long as the internet board didn't die. And I've also, in the firmware I've built, it's got like a history. So it keeps data recorded until the EEPROM, because it's got a memory in here, until that starts to get full, then it will stop. So it's got all those backup features, which is quite nice. Right, so I've got that voltage detection, backup battery, and then temperature sensors. So there's one on the board, but I've actually got headers here where you can have an external temperature sensor that you can take to the battery, because that's all this board is trying to monitor that battery. It has a few extra features in line just to monitor the battery and report that data, and also allow people to speak to it to do things. Okay, so that's it. And I also added a speaker and whatnot, but I think that's on the next page.
So technically, remotely, we're able to monitor that repeater site to see has it got power, status of the battery, is the battery low, has it gone flat, is there no power, and those things will help us. So we don't have to drive all the way there. Before we get there, you've got an idea of what's happening.
Yeah.
That's good.
Okay. So the next part about this is I'll get to the speaker now. So it's the high resolution ADS. So it's an analog to digital converter. So that basically, because the chips that I'm using on here is it's measuring an analog signal. So it's like a small voltage. So that's another thing I wanted to test. Will the RF have an effect on it? I might have to add some filtering and whatnot. But it's going to measure that that voltage from the different sensors. So like measuring current and whatnot, it's an analog voltage. So it's a voltage that the chip measures, and it needs this extra chip to have a higher sensitivity, basically. That's all it is. So it can have a more accurate result when it sends it to you. So instead of like telling you, oh, it's only 12 volts, we tell you it's 12.657 volts or something like that, just as an example. Then of course the I/O expander, so the inputs and output expander, so that chip is over there. That just expands all the little peripherals that I have, so I don't have to use the chips on the board, and it also creates like a buffer zone. So if something gets damaged, it will be the I/O chip instead of the main chip, so there's a little bit of a buffer there. And then other things like the OLED screen, I told you guys about that earlier. You know, I thought about removing it. I removed it on other versions. I'll still decide, but on this version it exists. Reset button, so that's just to reset the board if there was problems. Like of course goes there and there's a problem, you would reset it. But most of the time they don't need to be, as long as you're familiar with how the process works and that. But it's mainly for myself. So while I'm testing it and I want to reset it, you know, maybe start from somewhere else. Then there's a control button, so that was for the OLED screen. So using the control button to view information. And then I've got holes that are M3 size holes. So that's for mounting this board, so it's in a nice little case. So it's not going to be damaged by the elements or whatnot. It's got a little bit of protection, and then it's got USB-C coming in. So it's got a standard USB-C, very common, very nice little USB charger. Most people have that with their phones nowadays, unless they have a micro, but USB-C is very common. And then I was thinking of actually having this thing measure names, okay? But then the problem is, it adds a whole lot of extra complexity to the project. Now you have to actually have physical holes to be compliant, and you want to be compliant. I mean, I could have had my own antenna. You can build your own antenna on the board and have it there, but the problem is, it's not FCC compliant. When you get a module like this with the antenna, see it's sticking up there. This antenna has been tested, and the guys have paid, tens of thousands of rands or whatever. Nowadays the guys do that when they have their own antenna, which to me it's a little bit too expensive and a little bit too if it became a commercial product, I would then do that. But this is now just for the club, you know what I'm saying? It's not something that I would be selling, at least for now. Maybe in future there would be something, but for now, this is something to help us measure things and hopefully get some things online and get people interested. I'm sure there must be some people that are engineers and whatnot, or that would be interested, in making their own board even. Getting people excited, because that also means more members for the club, So it is what it is. But and I have circuitry for charging it here, lithium ion, and I've got protection for that as well. So overcurrent protection, and if it drops, the voltage drops too low, so the voltage cutout protection. So I've got all the protection added in here. So I considered a lot of things. And this I was working on since, I think it was November last year or December. So it's been a few months, but it's not like I've been working on it full time. I've done probably like 15 boards, but they're all at the same time. So you allocate a bit of time on different projects. So this was one of them for the club basically. And then this was another one for the club, but I never designed this one. This one was just one that I got printed, because everything is already designed, and you just populate it. That's what I did. I populated this, and then I have the software to program it, and then you just plug and play, and you just need the IP address and whatnot for the club, because they'll have their system set up. Alright, so then I've got a speaker. So that's just nice to have, but the speaker's not necessary. It will just make a beep, maybe if you walk up to the box and you hear it making a beep, you'll know, okay, that means something. And then notification LEDs. So in this corner here, there's some notification LEDs. So it's the basic stuff. And then it's just what it's made of. So I've got a FR4 dielectric, so that's basically fiberglass and plastic. It's like an epoxy. So you don't want to breathe that stuff in. If you ever cut fiberglass or whatnot, it's like flipping asbestos. It's like pure cancer that you're breathing in, so you want to be careful. So, but it's a standard thing. There's nothing fancy. You get fancy like aluminium boards that they use for LEDs, and they've got a thin layer of insulation, and then they put tracks on top of it. It's interesting. So there's many options, but FR4 is just, that's all you really need. And you can have thinner boards and whatnot. This one is 1.6 millimeters. but you can go down to I think 0.8, and the factories will still accept that without adding extra costs. Most of the common factories, because you get this thing manufactured at a factory, you can etch your own, but it's so affordable nowadays to get this from a factory in China. You know, if you're buying in bulk like me, if you do a few projects and whatnot, and then you get it with the shipping, then it becomes affordable. So yeah, and then I just leave some leeway for tolerances. I've got the standard PCB fab house constraints, so that's here on the left, like I saw on the right, but I don't think anyone will be interested in that, but that's just for whoever would be interested in like the constraints of the board. You know, it's like diameters of things and the sizes and like, you know, how thick the metal is and whatnot, you know, the copper. But anyway, so yeah, you can get all of so they'll give you constants. So constants you need to get from the factory, because certain things you can't just work out yourself. You can design the board, but there'll be a constant, like the light that goes through the board. You know, so you need a constant for that, because basically electricity is the same thing as light. It's just on a different frequency. At least that's what I've learned. But you know, so you'll use that in a calculation, and light, the speed of light is always the same thing. So anyway, getting too technical here, so I won't bore you guys with that. So the next thing is just concern. So for the repeater side, I just had a few concerns. So it was basically, will the Wi-Fi work reliably? Because we've been having so many issues, and the recent one was the Wi-Fi. For some reason, I don't know if it was data or what, but or the board itself was damaged and someone needs to look, or you know, but it seemed to be, at least this is again for Griffin's Hill, there was issues with the Wi-Fi. And then of course for me, keeping wires as short as possible. So when you use something like this, you don't want your wire, which is power, you don't want that to become an antenna now, or unintentional antenna, because it's possible that that could happen. So that's just for me, and just to make a note publicly that you're going to try and keep the wires as short as possible, but it's not thing. Then lightning protection. So I don't know how good it is. I don't know, you know, it's expensive. If lightning strikes something, you're going to replace everything. And I looked at the prices, like getting something like this, 7 to 8 grand. Then you're still paying shipping and whatnot. Not this particular one, but getting the surface mount one, which you would get overseas, are very expensive. This one, you know, I've got the costs. I'll look at them just now. But it's a couple of thousands. It's about maybe half to, you know, maybe 2/3 of the price, but it's more affordable. Building your own thing. Of course, now I'm putting my own labor in soldering this thing and testing it. But that's just to give people who like costs and who like numbers like that an idea. At least in my personal experience when I ordered parts from overseas, and certain chips as well, I had to get from America. You couldn't get these chips, they were very scarce. So you either had to get a suitable alternative chip, or you had to order that specific chip now from America. And that was a bit of a pain, especially we don't know now what's happening with this nonsense in the political sphere and whatnot. But you know what, I wanted to do it, so we did it. Anyway, back to this thing. So yeah, fuses between all the power in the box. So that's basically, if I was using this, wherever there's wires coming out, if it's not an antenna, you should have a fuse on of some sort, you know. And then maybe we could add a Wi-Fi camera. You know, it's like $1,000 basically. And here I wrote 800 to 1.5. That's not that I'm asking for that, but I'm just saying it's a nice thing. You could see the rats. If they start eating the repeater that's like 15 to 20 grand, you can see it with the Wi-Fi camera. Maybe you can activate a siren or something, or, you know, I don't know. You would like to prevent that stuff and not have to actually activate it, but you know, you want to be proactive rather than reactive. But that's just my opinion. I was hoping to have more people here to talk about it, but the guys will maybe watch this video. Unfortunately, again, I wasn't recording the first part, but I got most of it. So yeah, then there's just some interesting facts. I don't know if you guys will be interested, but that's like what I was talking about, the built-in antenna here at the top. Where it's nice that the Wi-Fi module has this, so you can see I'm circling it there. It's got this built-in antenna that's been FCC, whatever, regulated, which is important. You know, I'm saying it like it's not, but it's important that they check that it works and it's safe and whatnot. But it's an extra pain. There should be an easier way to do that, to get that regulation, or somehow, you know, you can do it as a hobbyist. You don't have to care too much, but once you start doing things professionally, then you have to start worrying about that. And if I wanted to give this to people, you can't really give them some homemade thing and feel good about it, you know what I mean? It has to be tested and whatnot. But yeah, so basically I just say a few things like, you're going to create your own antenna, it's going to cause extra costs. You can use an SMA connector, so you're not forced to use a module like this. You get a similar module that doesn't have an antenna, but it has a SMA connector, so you can get a separate antenna and just clip it on if you wanted a higher gain, you know. And that's what I said, yeah, it's the best for hobby projects, because you could technically make, like this is an SMA connector, basically on these radios. If I take this antenna off, I can use this antenna and it should be fine. You know? So you get a module like this that allows you to put that on there, because this one technically, it does have a document somewhere that says it's compliant. I just don't know where that document is, but technically Nagoya should have a document like that. So that's basically just about that stuff. Yeah, and then shielding. So basically shielding is important because of radio waves. Things must be shielded. So I just said consider shielding and whatnot. So, you know, it is what it is. But yeah, let's get on to the VOTER. So what it stands for, voice observing time extension for radio. But you can just call it a VOTER or the RTCM, the radio thin client module. You know, that's the SMD one. It does the same thing, but it has different names because technically it is a different board, but it's the same chip. It just has more pins. The SMD one is slightly different. So that's all technicalities, but yeah, it's affordable. So at the time before this board was created, it was very expensive. Voice over internet was very expensive. I don't know, you guys would probably remember, like people working in the, you know, with at the telephone rooms and plugging things in, and then they started making similar PCBs. And the companies started making big profits off of this, and then this fellow, yeah, Jim Dixon, and he created a much more cheaper. It's still pricey, but it's much more affordable, I would say, I guess, rather than cheap. And it makes it available to the common ham. Like if you wanted to have your repeater site now on your farm somewhere, you don't need to now go and call some guy that's got a radio dealer's license. I mean, I've got a radio dealer's license now, I've had it for a while, but you don't need to. Some of these guys, they just want to make money or whatnot, you know. And you know, I mean, of course, it's a business, but sometimes, you know, people take advantage of people who are ignorant of the truth, or you know, so. But at least in this case, you could experience, you know, experiment it, you know, and also experience the way it works and the technicalities and all that. But yeah, so I just wrote a bit about the VOTER there. So it's got filtering, it's got all that protection. The guy who developed it definitely took all of that stuff into consideration, which is nice. And he made quite a good solution. And he is the guy, the all-star system. He started that basically. And there's been some issues because there's a hand VoIP, which is a separate thing. But apparently that guy who made hand VoIP was working at the all-star with the guys. Or, you know, there's some drama. So that dude has his own business, and then there's the all-star network. So people sometimes get confused between the two. I try to stay out of that, but it's important to let people know, because we're experimenting with this. Here's my all-star node. I was also now confused. Who must I use? All-star node standard website, or must I go to the hand VoIP? And when I went to the hand VoIP, I couldn't get the software to download it. So I just went to the all-star website, and it worked. And then I saw, after reading, they had this drama, you know. So, but it's just something to take into consideration. So whatever. But yeah, so of course this one's not sold commercially. It requires you to build it and whatnot. The commercial one is the one that I was hoping Koos would be able to bring today. But of course he's not feeling so well. So it's bad. Yeah, it's been cold these last few days, I must say. But yeah, let me continue here. So basically that's what it offers. So it offers your internet. So you get the internet connection. So on the internet through Wi-Fi, through the Raspberry Pi, but on this one you just plug it in here as a LAN connection. So you still need your modem, your 4G modem, and then you plug that into here, and then this acts as the sound card interface and whatnot. You connect to it and you program it in there. So I've got it written here basically. 6 pin, 5 pins for GPS. You can add GPS in. You know, that's for if you were going to do multicast. but there were some problems. But the solution that this board was, what this board was trying to solve, was basically allowing you to have multiple repeater sites overlapping each other. And as you drive through it, so if this is the repeater site here, is you driving, you don't even notice. It's a seamless integration for repeater sites. So let's say I was driving from Johannesburg and there's a All-Star node there, and a voter on that repeater and a voter on that repeater and a voter. You never notice. It's like your cell phone carrier. There's no place where there's a dead zone. So the people that set up the repeater sites were supposed to do it in such a way that everything is covered, and in this All-Star, this voter, through the internet and through timing, because it's got a timing crystal that uses GPS to time. So that's how it knows to keep everything in sync, so that it's seamless, because now it's synchronized. So as you're going, it's in sync. Anyway, that's just the basic thing. I'm not going to get too technical with that. And then it's got a PIC microcontroller, so by microchip. PIC, which is a long-term, the chips, so they manufacture a chip and they guarantee that chip's going to last for 10 years. So that's why it's a good design. The guy chose that chip because it's guaranteed that it's going to be available, because there is a lifespan. Every chip has a lifespan. Nobody's using, or very few people are using, the old, old transistors and tubes from the old days, the 1940s. Nobody's using that really, unless you're a collector or something. So that has a lifespan. So these chips also have a lifespan. Anyway, and then potentiometers. So it's got pots, and you can adjust the squelch and the volume. So you do have to fine tune it. When you put this board in, you have to sit there and fine tune it so that everything works correctly, which does require a little bit of extra work. But yeah, let's get into my experience. So basically it took me 3 days and a little bit, because I got these chips later. I got these chips yesterday and I just threw them in here, just so that it's populated. But about 3 days to build one. I was chilling there soldering it and whatnot. I've got some photos here. I'll show you just now. I had to order some special ICs, integrated circuits. So I had to order some special ones from America, and some of them had to be substituted. So certain ones of these, there's many copies of the same IC, which is nice. So I could substitute them, because if you try to search for them, you might not find it. So you'll have to substitute certain things. Anyway, that's just the point. The main CPU had to be imported from America. And then I've got some numbers here. So basically, just for the PCB, so with importing and all that nonsense, because that's the thing, you can have it sent at the post office and it does work, but it takes a long time, and sometimes there's issues and you can't guarantee success. So these boards, if you have a project like this, just get it from FedEx or DHL. It's going to be a little bit more expensive, but you got to do it, you know what I mean? You got to do what you got to do. The problem is you pay for it, unless you have a specific business account, you pay for it from DHL and whatnot. When it arrives here, you still pay taxes again on it. Taxes that you're paying to SARS, to customers basically. So that's why it's so bloody expensive. You can see 895 Rand and 86 cents. That's a bit mental, but it is. So that's just for the PCB. Then for the parts, luckily these are the parts that I was able to get. But as you can see, it's around 2.5 to 3.1 grand. So altogether it's about 4, 5. So it can be quite pricey, but it's a lot cheaper than getting the radio thin client. So that's the surface mount one. Although this one doesn't come with a nice case and that, but I've got a few boxes that I've set up. I'll have some follow-up pictures in the future that this can fit in. But there you can see on the right-hand side, if you look there, that's the surface mount version. That basically does the same thing. But of course, the company that is running, from what I understand, is also going out of business kind of. You can still order the boards, but I think they do it on special order. You order it from the individual in America, and then he will create a bunch. At least that's how it looks like, that's how it works. I haven't tried ordering one, but and it's pricey. You're going to be paying almost 8 grand, especially when it arrives here.
And that's the shame of it, man. If only the currency was a bit stronger. Every time I look at chips and whatnot, I have to convert it from dollars to rands, and then I have to add things on it, and it's just depressing, I can say. But it is what it is, man. So things are just going to keep getting more expensive, and what can you do? But I wanted to do this project, and of course, so I invested some time, and I wanted to make some boards, and I wanted to do a good job, not just something stupid, but Okay, so I've got some differences here. So there you can see I'm soldering it there. You can see I actually put the schematic in front of me, so it's important to do that so you can tick things off. So once you've like soldered something on, and you just mark it off, and it just helps doing a good job. But that's a good a good standard to have. So anyway, but the differences. So this is the through-hole version, so THT. So I just say the differences through-hole components. They are much larger. So as you can see, through-hole components are much larger to SMD ones. There's no case, so there's no case for the board that you will get, and the parts are a bit old. There are substitutes, but the parts are a bit old, and at least they are cheaper than the RTCM, but they're on their lifespan is ending basically, so they're on the down low. And of course, you'll have to program this board. So after you've done all that work, then you still have to get into the software. Now you've got to plug it in. But for me, it's nice and I'm familiar. But I'm just saying for another person, it might be a bit difficult. And then of course, assembly, like soldering. Even for me, spending 3 days on this, it was okay. But I was like, eventually you get tired of it, But I'm happy I did it, That's a good thing. Then the other differences I've got here, so this is the SMD version, so you can see there's two here, SMD version on the bottom and the through-hole version on the top here, just to see. And it's SMD components, that's basically it. Smaller parts, comes in a case, and it uses a slightly different main processor chip. It's got more pins, but it's essentially the same model and make. Inside the chip is the same, it's just an SMD version. And then of course now, because it's a bit difficult to get a hold of the guy and order it, they're very expensive, and the shipping is going to be crazy from America as well. It really is kind of expensive getting things from China, but from America it's always more expensive as well. Unfortunately, that's just the way it is. Getting things from the Western world much more expensive than getting things from the East. So yeah, and then of course it's programmed from the factory, so you don't have to program this board. You will just have to put in the IP address, because it connects through the internet to the club's all-star network. So you would have to have your address of your server. So whatever server the club is hosting, you would have to just put in there. But you don't have to do hardcore programming. You'll just put that address in the board. Okay, and then how does this benefit the club? So for me, that's what I was thinking, how can I do a little bit of a talk, but also have it, beneficial to other people. For me, it's nice to share this on a day, but you want to try and have it help other people, or help the club, or get people excited, or something. But basically, the first point is that we can source it locally. So now that I've learned how to get this thing, I can do this now. You know what I mean? So we can use these. If we have a problem where we can't get a hold of those other boards, yes, some of these chips are difficult to get, but I have a few, and they can be used now. So we have that capability now, where we don't have to rely on purchasing something from America and then waiting for it and paying all those extra tariffs and tax and stuff from SARS and whatnot. We can just make something like this. Of course, we'll have to get hold of those parts, but we can do it. And if there were people interested in this, if we had some younger guys in the club, some younger girls or whatever, then it's a board that you can do. You can have it as a project, do something interesting, and they can put their name on it, and you can put it in a repeater site, and then you've participated with the club, and you have a fun day or something, So that's the educational aspect. So I've got that as my second point. So just doing that type of thing. It would be nice if I see there's a lot of other clubs doing things, and they're getting they're dominating now. We're no longer dominating. What's happening? we need to start doing some things. Let's try and, you know, we don't have to use that terminology I use now, it's a bit, you know, but, you know, it's, yeah, anyway. But I'm going to post it on the website as well, so that's just for our reference. So in future, the documentation, because that's the other issue that I had. Before I knew anything about this board, there was no information. Members of the club had worked with them a long time ago. Some people knew some knowledge about it, but it was a mystery, you know, and it's okay. Sometimes you want to be, you don't want to give the passwords to everyone. But this type of thing, it's not a nuclear submarine, you know what I'm saying? I mean, come on guys, like, if it's club members, it should be okay. You know, you'll keep them safe in a safe location, and you'll obviously have people you trust use that information or work on these type of things. Or you can just change the password afterwards. But the point is, we need to know how to make this thing again. Because how are you going to, when you have, you know, issues? I mean, there's other boards that we could potentially take a look at. And in future, who knows, somebody else can make, I still want to try and attempt to make something similar. I'll just see if I can balance my time. A much more advanced version of this, you know, use some readily available chips. But the biggest problem is the MCU, so the processor, because that has a software that you have to make yourself. So you have to be very particular of what chip you choose, because you have to still build the software. After you design the board, you'll have to, you know, either have help. And that's why it's much better to have other ham operators around the world that have designed the board share it, like this guy, who's silently now, Jim Dixon, but he shared this thing. And, you know, unfortunately he's not alive anymore that he can, but, you know, that he could see, oh, it's actually helping people. But he did see that beforehand. But, you know, you want to, you know, give back to the club, because that's what you do at the club. So, you know, share and things, you know, whatever. So, the other thing is advertisements for the club. So Mark doing things, so that's basically what I just went over now. So it's something else to do. I know guys are into the HF. HF is overboard nowadays. It's like very important, you know. So at some point I'll get into that as well. But for now, I'm, you know, focusing on what I can. If I was focusing on HF, I'd probably have to be either a millionaire or I'd be very poor, because there's so much stuff to buy. At least with this stuff, I can still get it at a reasonable price. You know, it's expensive, but it's still reasonable, and I can do this board. But with HF, looking at 50 grand for like one radio or something, it's a little bit. So I can understand why people are excited about that, but it's also, it's a bit, it's not educational. Yeah, you know, it's not like every person can get it easily. So yeah. But anyway, right, back to the slides again. So yeah, how does this benefit the club? And in the last picture, I thought it would look nice. At least I see it's a little bit darker, so it looks a little bit nice. The sun's not washing out the slides anymore. But why do we go to club meetings and make an effort? Like today, unfortunately, we had a bit of a flop, but why do people make the effort? So, you know, it's basically to keep the hobby alive, you know, keeping it alive. You have interesting topics, it's something to do, you know, you're chatting with friends and colleagues. I've got that as a point there as well. Networking, so some other people will just do networking and potential business partners and contractors and things. So they'll come here and they'll be scouting to see if there's somebody that, you know, that they could communicate for financial reasons or whatnot. And that's okay, many different reasons. Sponsoring, you know, scouting for sponsors, it's like people that play rugby. You know, you might want to go to some of the meetings, and then there's always the people are looking for sponsors. You know, they want sponsorship, sponsoring a uniform for some kids or something. So it's a normal thing. And then there's some people that are just retired and they just want you know, something to pass the day. So, you know, once you're retired and you're relaxing and you're not working so hard, you want to just sit all day and be on your radio and have fun because you've earned it. You know, you're retired. So at least that's how I see it. And I've got this photo here. It would be nice if we can have an update. You know, I think we've got some more members, Richard, you know, so we can add some more guys to the photo. Maybe at the end of the year we can have something.
Maybe you could do that either at the AGM, provided people are there, or the Christmas function.
No, we always keep the old photos. We never get rid of them. We just add the new ones so we can see how the club progressed through the years.
It isn't this one.
Yeah.
Roger is not there anymore.
Yeah.
Gudrun isn't.
Yeah, no, it's just to add more members and yeah. Anyway, so that's basically the end. I'm at the end here. I had a few jokes, but yeah.
Do you want a few?
That's
So
about
we
it.
can go to the roof, then you can talk to us about your.
Yeah,
your
sure.
project.
We can try and call the guys now and say, hey, where are you guys now? What's happening? We're calling you from here.
So
This all started.
We'll close that and then we'll have a short break and then we'll